Hi guys. So I just recorded this whole thing and it had no sound. So we're gonna try this one more time. I should have done a test. That's the lesson I've learned. Always do a test before you do the actual thing. Okay, so let's see if I remember everything this time. Well, first of all, welcome to my kitchen. This is my current office. We are learning about volume, and so far you have done 11.4, and that's it. So that was a good intro into three-dimensional figures because it talked about like cross sections and your rotational, rotating around an axis. So cross sections, if you don't remember, is when you cut a three-dimensional figure. It's that shape that's created on the cut side. So some of you gave some really cool examples of that. Like someone said they cut a can in half. I would like more information on that. A lot of you said like cutting a cake or cutting a loaf of bread. My go-to is always like slicing a carrot or a cucumber because it could either be a circle or if you go diagonal, it could be an oval. So that's cross section. And then the rotational or revolution is when you have an axis and you rotate around that axis. So I always think of like a flag rotating around a flagpole. If it drug and you saw its path, it would create a cylinder. So, but that's not what this video is about. This video is about how to find volume of three-dimensional figures, and not all three-dimensional figures. We're going to break it down. So 11.5 just talks about cylinders and prisms. Cylinders and prisms. So a lot of you were okay with knowing the difference between prisms and pyramids and prisms, but some of you not so much. So just so I can clarify that really quickly, and I really regret not bringing home all of my three-dimensional figures that I have. But anyways, we'll make do. So a pyramid is going to have a base, but just one base. And that base is going to sit like this. It could be any shape. It could be a triangle, a circle, which is really called a cone, a rectangle, a square, a pentagon, hexagon, like literally any polygon. But it would sit like this, and then all of the edges would have a triangle, and they would all come up and meet at a point. And it doesn't have to sit like this. It could sit like this or like this, okay? Doesn't matter how it's sitting, but it only has one base. A prism, which is what we're talking about today, has two bases, okay? And they are always identical, or in geometry, we would say that is congruent. They're always congruent, and they're always parallel. You can see these are my wedding RSVP cards. That's all I have. Okay, so, and these are connected with rectangles, okay, all the time. And these bases could also be whatever shape, any shape. They just have to be the same. So that's the difference between a pyramid and a prism. Today we are just talking about prisms and a special type of prism, also known as a cylinder. Okay, a cylinder is just a prism, except the bases are circles. Okay, so the volume is all the same, whether you're talking about a prism or a cylinder. It's all the same because they're the same shape. And this is on your air test formula sheet, which I don't know if this is official, but I did just get a text saying that those aren't happening. But I have not read that, like, from an official person, so I don't know. Okay, so the formula, and this might be backwards. I will post a picture of it later. But the formula for prisms and cylinders is all the same. It's going to be capital B, H, where capital B is the area of the base. It's not just the base, okay? This is three-dimensional now. So we're not just doing base times height. We're doing the area of the base times the height. And that should make a lot of sense because if you wanted to find, this is a prism. This is the prism that I have right now. If you wanted to find the volume of this prism, you would find the area of the base. It doesn't matter which one because they're the same. So So I would measure, I would measure this, I'd say this is like 5. And I'd measure this, and I'd get about 3. So this would be 15. And I would take that, and I would multiply it by the height. So this is about 1 inch. So it would be 15 times 1. So the volume of this is 15 cubic inches. Area is 15 square inches. Volume is 15 cubic inches. Now, if you were talking about something else that's not 1, I don't have anything around right now. You know, it would be more than 15 if it were like double this. Maybe like my notebook. Yeah, that's more like 2 inches. So let's say this is like 5 and this is 7. I don't know. But 5 by 7 would be 35. And then the height of it, you would do that 35. Let's say this is 2 inches. So you do 35 times 2 and get 70 cubic inches for this prism. Okay? Now, what if your base was a circle? Then we're talking about cylinders, okay? And it's the same formula, except how you find this capital B is different, right? So to find the area of a circle is how you find that capital B. So the area of a circle is pi r squared, right? So we're just gonna use this. This is all I got right now. So this is a cylinder. Just pretend it went straight up and down. So we could measure this circle and do pi r squared, find the area of this circle, and then multiply that by the height, okay? Now, there are so many examples in your textbook of all of this, and I can post some more examples online that aren't so spontaneous. These are going to get so much better as we go. Okay, this is the first one. I'm hoping. Okay, so the last thing I want you to take away from this is that it doesn't matter if your prism or cylinder is straight up and down or if it's slanted. Straight up and down is called this is called like a right prism or a right cylinder when it's straight up and down. But what if I slid them over and made it slanted? Did the volume change? No, because it's the same amount of cards, okay? The height didn't change either. So you would find the volume the same way. You would take this, which was 5 by 3, multiply it by that 1, and you would still get 15 cubic inches, okay? Just because I know you're going to see this. So your base could be a circle, which is pi r squared. I'm going to write that down. Could be a circle, which is pi r squared. It could be a triangle, which is 1/2 base times height. It could be a rectangle or a parallelogram, which is always going to be base times height. And that's probably all you're going to see. Okay? So I will post this separate from the video. But what I encourage you to do is read 11.5 in your textbook. Look over the examples, read the definitions after you watch this video. And then try the Big Ideas math assignment. And it shouldn't be super crazy. But you can message me on Canvas. You can message me through email. You can do whatever is easiest for you so that you can get your questions answered. I do check my email all day. So just let me know. Okay? I will see you later.